It is capable of storing multiple data sets and can perform field checks to verify the validity of the measurements. So when you are saying about an working principle, actually the inclinometer deflection devices comprises of the servo cable, cable reel, accelerometer probe, and decilometer, which we care should be taken while setting up these instruments to take a set of readings by ensuring that the guide wheels are checked for bearing free play and tighten if required. Lubricant should be applied to the wheel bearing assemblies. The cable connectors are protected with caps to prevent damage or contamination to the connector contact. An O-ring is used to provide a watertight seal between the probe and the cable. Readout unit is turned on and the system is checked by holding the bottom of the probe in a stable position while moving the top along with the measurement axis, that is the two upper wheels. The readout unit will display values with polarity matching the given tilt angles. The reading can be interpreted using basic trigonometry. And when you're saying about an working of inclinometer, we'll have a servo accelerometer, lens accelerometer. The force balance sensing elements housed in an inclinometer probe, which detects the changing in tilt from reference. The probe consists of a couple of biaxial servo accelerometers. It is fitted with two sets of spring pressure wheels to guide the probe along the longitudinal grooves of the inclinometer casing. MEMS accelerometers. Such inclinometers are termed as MEMS inclinometers. Currently, the MEMS technology is being used to build a tilt sensor probe. The MEMS consist of a mechanical element, sensors, actuators, and electronics on a common silicon substrate through microfabrication technology. Acceleration causes deflection of the proof mass from its center position. There are 32 sets of radio fingers around the four sides of the square proof mass. These fingers are placed between flats that are fixed to the substrate. Each finger and pair of fixed plates makes up a differential capacitor. The deflection of the proof mass is determined by the measuring the differential capacitance. By this method, both dynamic acceleration and static acceleration can be sensed. Signal conditioning is carried out within inclinometers so that a simple output signal is obtained. This output can be used in conjunction with a calibration sheet to usually calculate the amount of tilt that has occurred over on it. Okay, and apart from that, when you are saying about and types of inclinometers, we'll have a broadly divided into two categories. One to be the inclinometers that use a gravity actuated pendulum or other indicators, inclinometers that use a spiral split dial. Model inclinometers use various technologies. The following are some examples of inclinometers in combination with other technologies. We'll have an electronic inclinometer, mercury inclinometer, manual inclinometer, and gravity inclinometer. When you're saying about an electronic inclinometer, actually this enables very precise reading of angles. This type of inclinometer uses the internal gyroscope to measure the direction of gravity's pull. The gyroscope remains in one position no matter the orientation. The solid object is placed along the gyroscope and the angle between the gyroscope and the object is determined via the inclinometer and displayed on an electrical node. When you are saying about a mercury inclinometer, it is similar in operation to an electronic inclinometer, but instead of gyroscope, we'll be using mercury liquid. Whereas in the case of a manual inclinometer, actually the older model will be to be named as a gas bubble type. So this instrument which contains a glass tube with a liquid and we will have an air bubble infilled over on it. So when the instrument moves, the bubble stays level. Its position indicates the inclined angle on a scale. When you are saying about a gravity inclinometer, one of the most practical gravity inclinometer was invented by William B. Mellick in 1889. This instrument consists of a rotating scale and fixed pointers. The scale is driven by an internal pendulum light. The weight is fastened to the back and suspended from a bearing, which is supported in the front by a diagonal crosspress. So when you have two buttons on the instrument, it can be pressed so as to lock the scale firmly in place to enable lace reading. This instrument is considered to be a sturdier and more practical design because whatever the orientation, the weight is kept down by gravity while the scale moves. So when you're saying about its applications, actually we'll have a different monitoring, landslide monitoring, monitoring slope stability, monitoring excavation, monitoring during tunnel traveling drilling, monitoring file and drill fire performance, and applications areas which is to be given as a for determining latitude using Polaris or the two stars of constellation cruise, or for indicating a deviation from the two vertical or horizontal, to alert an equipment operator if a machine may tip over, for monitoring the boom angle of cranes and material handlers, and similarly it can be for the use in structural geology for measuring the inclination angle of the pelvis and measuring range of motion joints of the body. Okay, the gyroscope that we can see in the next class. Thank you all.